We can also probably check out what lender is about. From the past two contracts, we know that fees is the fees contract. Essentially, it's only used for selling different tokens that are somehow accrued in the system for ETH. So we can send that ETH to the staking contract here. So we can probably piece our picture up that we have probably lender as the main contract, staking as a mechanism for rewarding stakers, and fees as the contract that is actually going to reward the stakers by transferring tokens to the staking contract. Then we proceed on to the lender contract. We see again that it has a lot of events defined on top, which is kind of overwhelming when you see it at first. We see some basic constants. We see that there's some sort of an interest rate, so this is definitely some sort of a lending protocol probably. We see some auctions, fees. Then we have some setters, which we don't care much about. We only check whether they have the proper modifiers. And we can probably also return back to them at some point and check whether they update the variables properly, but we can offload that complexity off of our heads at this point.
Kristian, what do you think of the good old only owner issue rates for being the how is that called, the main point of failure, having only one owner and not some roles or some admin?
I mean, it's definitely an issue. The thing is that we need to abide by how the contest platforms see issues, and contest platforms don't see this as an issue just because the clients, which are the protocols that we audit, just want their protocols to be that way. And essentially, the rules are determined by the people who pay for it.
Yeah.
Yeah, so it's definitely an issue. If conducting some other type of audit, it definitely needs to be raised just because it can probably bring a lot of issues. But in contests, we can safely just not care about them that much.
Usually I've seen it mentioned even in the bots race issues, to be fair, like even as a medium. In Code Arena, I mean.
Yeah, it's a medium in a bot race, but not really in a actual contest, because sponsors know about those findings, but they don't do anything with them.
Okay.
I mean, they are the people who wrote the contract. They have power over what happens and what doesn't. We see some get functions again. We can also safely skip them, just because in most contests, for a value that is untrue from a getter function is low, just because it doesn't make any other unintended behavior. If it provides a false value to some other part of the protocol, it's definitely an issue. But if there is some sort of a issue within those functions, like this external one, it is at most low, just because the only part of the protocol it can mess up is probably the front end, and we don't care that much about it because it cannot lose material value in some way. Like it cannot directly lead to the loss of money or break something.
It's impressive the experience that you have with the public contests and what the judges like or dislike, or what is accepted or what is low or medium. We can see that you've been through a few for sure.
Yep. Then we can check this function, which is definitely very big. It is for the creation of some sort of a pool, and it instantiates the user as the lender. So this is some sort, from what I remember, this is some sort of a peer-to-peer lending platform. So this is the entry point of a user who wants to lend some sort of token to others. They appoint the token that they want to be repaid in, I guess. They yeah, they have the loan token. They also have some other token, I believe. Yeah, the collateral token. So this is the instantiation function. There's some basic sanitations like outstanding. This outstanding loan check is, I believe, to check whether the pool exists in some way. It also checks the balance. Yeah, if we cannot probably, this is probably also a update function and not only a instantiation function. So it's checking whether the pool has some debt so that it cannot update it whilst there is debt. Then it does some very basic checks and it transfers more or less tokens to the pool and to the user depending on whatever the criteria is. Then if it's basically emitting created or updated, yeah, so it also updates it and then it's setting it. I mean, it's a very complex function from like it has a lot of if logic, so we can safely skip it for now just because it's complex, but it doesn't have any content to it. Like it isn't the main point of concern in the protocol because it doesn't strictly deal with the money flow of the contract, I guess. We can safely leave this function out for now just because it's very complex, but there isn't that much money flow into it and out of it. Like it doesn't control the money of the contract directly and how users interact with the money present. So we can probably skip it for now and go down to the meatier portion of the contract. Again, this is some way of the user replenishing some part of the pool balance, I guess, giving more supply to the pool so users can lend more. Again, something that we can probably skip. We can definitely check update pool though, because it may contain some breaking logic. Then we have remove from pool, which is exactly the opposite. Something that happens with some contests is that the getter and not the getter and setter, the two opposite functions like the add and remove or grant and revoke type of functions may have some inconsistencies which bring some unintended behavior, which definitely needs to be checked out. But from like first glance, they don't seem very strange. So again, we can go down for now. Then we see some more set functions, which are they're not like not admin functions, but they're lender only. So they simply change the parameters of a pool based on the lender. And then we go to the main function of the protocol, I guess, the borrow function, which is the way of users to get loans from the pools of others. We see that it's the logic is encapsulated in a loop, which means that it's made for users to take like multiple loans at once, which is a bit strange. Like, why would you take multiple loans at once? But we're not mainly talking about the design of the protocol of findings. Then they're simply destructing the variables from the object. They're getting the contract, and then we have some access control here. They're checking the loan size, they're checking the balance. They are not checking the. Yeah, I believe they are. Okay, they are.
And Kristian, when you see that loop with the borrows dot length, do you think about a potential DOS attack by the how is that called, by reaching some boundaries, like running out of gas?
In this specific case, maybe not, because the value that we're looping over is provided by the user in the call data. So maybe not in this case, but if the borrows were something that was in the contract storage or that was like updated by others, definitely.
Okay.
Yeah. Then we have some basic access control here. And then we are calculating the loan ratio. this is some very strange formula of actually calculating it. We're multiplying the depth by 1e for precision, and then we're dividing by the collateral. Again, this is definitely an issue for like the improper decimal calculation, because the collateral is most certainly not only going to be 18 decimal tokens, or the depth is not going to be an 18 decimal token. But again, this is sort of a very not unique issue, so we can definitely like mark it and be aware of it, but we don't need to think about it that much. It's something present like a lot. Then we see that some sort of a contract struct gets initialized. We see that we're inputting all of the needed params. I don't see anything particularly wrong with it. Then we are calling update pool balance again. This, we've seen this function plenty of times again, like over all the functions that we've looked at in the past few minutes. We definitely need to inspect it further. Then we see that we're updating some sort of debts, and we're calculating fees that we're paying to the fee receiver. There is always a fee to the fee receiver, which is a bit strange. And then we are transferring the user the debt minus the fees, which is again a bit of a strange practice, because when you get a loan, you want to get the precise amount and not receive a portion of it, which is, again, I don't think it's a issue particularly, but maybe some sort of a design flaw. Then we are transferring the collateral from the user. So again, this is a bit strange that we're giving the user the loan before we are getting the collateral, which again, probably everybody has been seeing those CRC 777 reentrancies. You can probably like get the loan, do something with it, and then have the collateral from somewhere. But again, this is sort of a trivial issue, so we don't need to bother with it that much. Then we are down to the repay function. Again, it's mostly we're first calculating the interest, we're getting the pool ID, and again we're calling the update pool balance. We've seen it so many times that we need to check it before we see anything else. And we see that it's actually very basic. It's only setting the balance of the pool to a new value, which is kind of underwhelming. I thought it's something much more.
Yeah, like some bigger logic or something.
Yeah,
Or some checks.
and maybe we can probably do something with that. Where were we? We're in the repay function, I believe. So yeah, we know that this is just a small set operation. So here it's setting the pool balance plus the debt plus the interest that is owed to the lender. Are we making the user pay that amount? That's the thing. That plus the, yeah, so we are making the user pay that amount. Here we're also transferring a fee from the user to the fee receiver again. So we're not only paying fees when we buy, when we get a loan, but also when we repay it, which is again kind of strange in my opinion. Like, I don't get it completely, but I mean it's up to the protocol. Then we're transferring the collateral back to the borrower after them successfully repaying the loan, and we're deleting it, so we do not like have some strange behavior where the loan needs to be repaid again or something. So we have a function which is about giving your loans to another pool. So I guess pools with similar tokens probably and similar interests can give essentially make the other pool repay their debt, not their debt, but like be the loan giver in that specific scenario. So something interesting, I guess. Again, we see that they have it in a loop, which is kind of strange. Then we're getting the loan that we want to give to the other pool. We're checking again some basic access control. We're checking for whether the tokens of each pool match. So we don't like give a loan with some different token to this pool and completely mess up the whole contract. We're also checking for interest rates, lengths, some basic access control. We're also calculating the interest of the loan, which is, let us see what it has. So it gets the time elapsed, the time in seconds since the loan was taken. Then we're multiplying it by the amount and by the interest rate, and then we're dividing it by 10,000 and then by 365 days. Why are we dividing it by 10,000 in this case? This is probably because we're using because of the precision that we're using for the interest rate. It's in how was the unit code? Check. It's in BIPs. So this is some small unit of measurement, so we can be more precise when like giving loans and stuff. An issue that might arise here is that like it's always dividing by 365 days, and I don't know if it's necessarily an issue, but what do we do when we have leap years and stuff like that? This may be another thing to like check and make sure it doesn't like bring any unexpected behavior, which it might. I'm not exactly sure, but definitely something to check out. Then we are giving the fees and the interest that we are like returning by the function. We're simply multiplying the fee by the interest. So we are taking the fee of the lender from the actual interest of the loan. So the lender is in a way paying for this. Then we're again dividing by 10,000, and then we're removing the fee from the interest. Again, we can return back to where we came off of, which was, I believe, this function.
Yeah, like Evelyn. Kristian, I have a question. Like, for instance, in this, since we started, you didn't take a look to the documentation or their website. Like, is it something that you don't usually do? Like, do you jump directly on the code, or sometimes you need to go and figure out what their fees, expectations, or their plan with any logic is, or you just look at the code and try to understand what they want to do through the code?
I usually do take a look at the docs, but this particular project doesn't have some good explanations. Like, they have a very small document, I believe, which doesn't explain much. So it's better to go off of the code and try to like figure things out. But if the protocol has a very good documentation, I'll definitely use it. Like, but in this specific case, they don't. So
yeah, I'm wondering how best or how do you usually find the invariants. So like sometimes they are set on their documentations or some maximum of something, or just some specific feature that they have, or if you get to, or if you just extract them, let's say, from their code.
I mostly try and help myself with the docs, because why would you spend the additional time and essentially struggle additionally when you can get all the answers right in front of you? In this specific case, we just cannot do it just because, we don't have any docs in this case.
Yeah. It's just something I used to do that I think it was not the smartest, or at least not the most fruitful. It was to go through more or less, not deeply, but going through the whole docs and then jumping to the code. But somehow it's not necessary. Probably it's usually fine to maybe take a look at the docs and then just jump on the code, and then from time to time jumping back to the docs and checking what the specific feature or function is expected to do. Like, is it something you you do as well, or you would actually go first through the docs and then start with the code?
This is exactly what I would do. So I would usually take a small peek at the docs for like 5 to 10 minutes, depending on how big they are, of course.
Okay.
Maybe even more. I try and familiarize myself with what the base of the protocol is, like what it's trying to do, the abstract of it. Like for this protocol in particular, you try to know that to understand that it's like a peer-to-peer lending protocol, that there's some sort of a fee system, that they have a staking mechanism, essentially the basics. And then when you stumble into complexity, like let's say this function, you try to guide yourself both by the code and also with the docs. Again, they aren't usually the best in most cases, just because they use some sophisticated terms or something that are not the easiest to understand by everyone. So they are not the best thing to start off with.
Yeah.
Most times, but they can definitely help if you try and rationalize them a lot, like trying to understand what they mean by what they say.
Yeah, makes sense.
Yep. Um, we move down here. I mean, we're trying to calculate the total debt that the loan has accrued up at this point, and we are then subtracting it from the new pool's balance, and we are adding it to the outstanding loans. A thing that arises in my head at this point is, if someone has a loan that someone else doesn't want to repay, can't they simply shit it to someone else and make them deal with it? Which is a little strange, but again, this is some sort of protocol design, which is again very strange. We can see how they update the outstanding debt and the balance of the other pool. So yes, they essentially offload the loan from one pool and give it to another, and make the other user have to deal with a borrower who doesn't want to repay. Then we are sending the fee to the protocol receiver, and we see that. Let's see who actually pays for it. So the new pool pays for the protocol interest, which is probably kind of bad, because you can make the a pool pay a very old debt protocol interest, which is probably going to be big, because it's like 5 to 10% of the interest of the debt. So this is probably a way to make like other protocols, not protocols, but like other pools, to lose some money. Then we're setting the new pool variables, like we're resetting it, we're making it start from now. Then we reset the auction timestamp, and we also add the total debt, which the user is eventually going to need to repay both the debt, the lender interest, and the protocol interest. Something that can be done in this case is for user to create probably like two pools, and constantly, not constantly, but like try and give the loans to the pools, and to try to increase the debt artificially, so that the user can will need to like pay a bigger amount of tokens at the end, which is a little bad, but I guess it can happen, probably. I'm not sure again. Just something that pops up in my head and can probably be exploited with like a little more thoughts going into it. Then we have a start auction function, which is probably to auction out your debt that your borrower doesn't want to repay. So let's say there's some sort of a debt of 50 WEF that the user hasn't paid for like 6 months, and you simply grow tired of it and decide to start an auction of the loan so you can liquidate their tokens, their collateral tokens. An issue that might arise here is that you can probably liquidate users at any point just because there isn't any access control on what the ratio needs to be. So a malicious lender can probably liquidate you at any point in time that they want, which is very bad, definitely. Then we see buy loan, which is again just checking for whether the auction has started. It's adding the auction length, and then it's calculating the auction rate. So the max interest rate is 10, so it's 100%, and time elapsed is essentially the time since the start of the auction. So this means that the way it works is that it becomes more expensive with the more time the loan stays for auction. Then we see that we're calculating interest again. We're calculating the total debt. I believe we're using the same formula as above, so this shouldn't bring issues, I guess. We're also updating the outstanding loans and the balance again, and we are trying to not trying to, but basically doing the same thing as in give loan. We're basically subtracting from the outstanding loans of the old pool, and we're adding to the new pool, and then we are subtracting one's balances and lowering the other. Then we're transferring again interest to the protocol, and we're resetting the variables. So this is again very standard, just as the other thing. Then we have some zap buy loan function, which is just creating a pool for us so we can buy out a loan, which is kind of strange. I don't get it. I mean, it doesn't bring a lot of. It's just like making two calls, first to set pool and then to buy loan, so we don't need to try and rationalize it at this point. And then we have seize loan, which is a way for anyone to seize a loan after a failed refinance auction. So it checks whether the auction timestamp and the auction length, so essentially checks whether the auction has passed. A thing that arises is that so each loan probably has only one auction, and I believe we saw that when you give a loan to another pool, you can reset the auction. So this may be some sort of way of messing up something by giving a loan to one of your pools that you created with another account. Then we are calculating some governance fees, transferring the tokens to the governance, to the fee receiver actually, but like the same thing. Then we are transferring the collateral tokens to the lender, and we are removing the fee from the lender, which is a bit strange again. We're making the lender pay for the malicious borrower, and we're removing the outstanding debt from the loans of the pool. I don't completely get how the function works off the bat, just because it's simply allowing the lender to seize the collateral of the user. This is again something related to the thing I talked about a bit before, regarding how a user, like a lender, might liquidate you. I'm not entirely sure of if it's still standing, but it can probably be done in some way. But again, the function is not very complex, so we can go down, check whatever else is happening. Again, we have it in a for loop. We're setting the needed variables. We're doing the basic access control here. This is a way for the pool to refinance a loan to a new offer. So it's essentially a way for a borrower to update their loan to new conditions, let's say, and maybe borrow even more or try and repay some debt and to keep their borrow amounts smaller, I guess. So it's checking whether the pool balance is smaller than the debt, which may cause issues because the debt is the new debt of the pool, which may be higher than the old debt. And also, the pool balance becomes smaller after a loan gets taken out. So, in this case, if there isn't much liquidity in the protocol, there might be a case where a user cannot refinance their debt just because there isn't any additional balance in the protocol, which is kind of strange. Then we're checking for the minimum loan size, ratio, the normal stuff. Then we're getting debt to pay. Again, this is the same formula as above, but it has a different name, which is kind of strange. They rename it constantly. There isn't like that much structure into the different formulas used. They simply name them whatever. Then they're doing the same thing with the update pool and the outstanding loans here. Updating the balance with the old debt and then adding the new debt. Then we get to this very complex piece of logic, which is responsible for how the funds get to and from the contract. We see that if the debt to pay is higher than the debt, we can probably can actually what is this exactly doing? It's transferring additional tokens to the user. So this is the case where the user requests a smaller debt, I guess, like they are lowering their debt. Then this is the opposite, and they are required to pay a fee here, and they are paying it only on the difference that they are taking out as a loan. They're paying the debt, and then they're receiving the additional loan tokens. Here they're paying a borrowing fee, and here they're paying a normal protocol fee, which means that you pay two fees in the case that you want to up your debt. We see that this is an if this is not an if else loop, but is not an if else statement, but an if else if statement. So we may need to look into what happens if debt to pay is equal to debt. Maybe it simply proceeds and that's it. But the issue is that debt to pay is calculated with the debt, the lender interest, and the protocol interest. So it means that if we don't increase or decrease the debt and we keep it the exact same amount that we owe to the protocol in terms of debt, protocol interest, and the interest itself, we are not allowed, we are not obliged to like pay any fees or debt, which is definitely strange. It might have a rational explanation behind it, but definitely keep that in mind and try to expand on it if there is an actual vulnerability here. Then we are again updating the depth of the protocol. We're doing the same with the collateral. Again, it doesn't check for whether for the case where the collateral is equal to the new collateral, but the collateral doesn't accrue interest on it, and there isn't anything happening with it, so we can like leave it out. And then we see one of the very obvious things in this function, which is that I believe this thing here, the pool balance, gets set right here, and it also gets set here, which means that we're removing the balance of the user twice, which is something very bad and very easy to see in the function, but it's definitely a very critical thing because when you update your loan, you remove twice the amount from the pool.
Yeah, that's definitely big.
Yeah. So this is definitely a vulnerability. Again, it's a little easier to spot, but it's something very bad, so keep that in mind. Then we come to the end of the contract and we see the functions that we examined a bit before. Again, I'm still a little concerned with how it only thinks of a year as 365 days. But again, it can just be a false concern here. Then after checking out all of those functions one by one, the way we did, a thing that definitely needs to be done is for me to try and mix and match all of those functions. I usually try and do that with testing.